I'm wazpam. The thing is, I hate spam, and I'm sure you do too, which is why I decided to further my Python knowledge by making a spam detector to keep my inbox nice and fresh. I'll be doing this by making a naive Bayes classifier and teaching it what spam is and what spam isn't. You might even call this machine learning. This technique is sometimes jokingly called idiot's Bayes online because it makes a really dumb assumption, but it actually works pretty well in the grand scheme of things. Firstly though, what actually is naive Bayes? This is a form of machine learning known as supervised learning, meaning we have to supply labeled data to our model so it knows if the email it's looking at is actually spam or not. To do that, we're actually going to need data and quite a lot of it. I could just go through my own spam emails, but you know, that's just not quite enough emails. I need even more spam than I already get. So, quick Google search here. Kaggle's got some pretty good data set, so if you ever wanted to do anything with machine learning or data sets, yada yada nerd stuff, you can always just go there. So Kaggle's downloaded about a couple thousand emails from there, and we are good to go. Some of these emails are actually really funny. Anyways. Naive Bayes has a pretty simple formula, which looks a little something like this. It's a lot easier to look at than it is to actually make into words and say it. So here we go. And also each item that we'll be talking about here is going to be called a token, not a word, because we're sort of looking beyond words. There's going to be things like exclamation marks, punctuations, numbers. So these are all just tokens. The probability of the category given the token set is defined as the probability of the tokens given the category times the probability of the category, all divided by the probability of those tokens appearing in the first place. Again, a lot easier to look at than it is to actually say. I'll leave a link to a really good explanation of naive Bayes in the description that you should definitely watch after this because I'm not good enough at explaining this. And it also really helped me when building this project. Firstly, we need to normalize the data. All I'm doing is looping over all of the words, making sure they're all lowercase, then separating all of the punctuations into different tokens. So like commas, pound signs, hashtags. And then finally, all the numbers are swapped out for a NUM token. This is because chances are knowing a number is there is really enough information for our classifier, and then we'd have to store every number, which is sort of just doing the most. For example, a sentence like, hello, I am wazpam and I have 5 pounds would look something like this. Next, we need to count all of the tokens that appear in this email, which is pretty easy. We can use a for loop and a hash map. Now that we have this for ideally every email, we need to work out 2 probabilities. These probabilities are pretty simple to compute and will depend entirely on our data set, but this is the probability of getting a normal email and the probability of an email getting spammed. These can both be calculated by just using normal division. We can call this our initial guess, which is going to be what we assume an email is going to be before we do any sort of actual classifying on it. Next, we compute the probability of this email being spam by taking our initial guess and multiplying it by the likelihood of every token appearing under that spam label. We then also do this to get a non-spam value, and whichever one is bigger is the winner. To calculate the accuracy of this, we need to initially split the data into training data and testing data. And it's pretty important we don't actually use our testing data to train this model because then it's already seen it before. We need to test it with unseen data. I used about 80% of the initial data set to train and then about 20% of it to test. And when testing with the unseen data, that's about 96% success rate, so pretty good. Some of the emails that weren't classified properly, for example, this one, which I'm pretty sure was a false positive. Well, I mean, it just looks like it's got a lot of punctuation. So maybe that sort of threw it off, made it think that it was a bit spammy. And on the flip side, this one has a lot of rare and unusual words that otherwise would never really appear, so it assumes it's not spam. This is because both the probabilities are so small. Not spam just had a slight edge because the frequency of these words is so low but not 0 because of this thing called Laplace smoothing, which means we add 1 to all of the token counts even if they don't appear. So nothing is ever 0. Since we're multiplying, if we actually did have 0, that would just ruin our result. That's why this approach is considered naive. We're essentially just assuming, based on a bunch of other emails, that our email is spam. We're pretending every word is independent, which is obviously not true when we have things like context and grammar and vibes. But that doesn't mean it's bad. It actually still holds up pretty well. There are a lot better ways to do this that would probably get you better results, but for a first line of defense, it's pretty good. Anyways, bye.